Hello, Informal Geometry students. So we are going to start with a new unit, and we feel kind of bad because we don't know how to get you the guided notes. We're working on that. We may or may not be able to do that. But for now, I'm just going to have you take notes on a regular sheet of paper. By the way, this is Mrs. Wiedrich. Some of these videos you will hear my voice, and some of the videos you will hear Mrs. Brennan's voice. We are dividing up the work so that we both don't have so much work to do, since we both teach informal geometry. All right, so the first section is going to deal with ratio and proportions. So a ratio is a comparison of a number. I'm going to put this in quotes so it doesn't look like the word of a number A and a number B using division. There's several ways we write ratios. Sometimes you'll see them written as fractions. Sometimes you'll see them with this colon in the middle, or sometimes you'll see it written with the word 2 in the middle. By the way, a nice thing about these videos is you can pause them when you need to, if I'm going too fast with the notes, or you can re-watch something if you need to see that again. So that'll be one thing that's a little different than actually sitting in a classroom, is that you're able to watch the video more than once if you need to, or pause it if I'm going too fast, speed up if you want to, I guess. All right, so then a proportion is an equation that states that two ratios are equal. So something like A over B equals C over D. All right, and then the cross product property tells us how to solve a proportion. So in words, in a proportion, the product of the extremes is equal to the product of the means. You know this is cross multiplication, so it doesn't matter which order you do this in. AD equals BC. Notice when we cross multiply, we make it into an equation. A lot of times I see students that'll make it into another fraction. It's not a fraction, it's an equation. All right, so a few examples of some algebra problems that you probably did when you were in algebra. So again, to solve a proportion means you're going to cross multiply. Let me see if I can focus that a little better. All right, so I like to have my variable on the left-hand side, so I'm going to do this part first. We have to take 3 times the quantity y plus 2, and that has to, again, equal, not make a fraction, make an equation, equals 5 times 6, which is 30. All right, what do we do next? All right, so next we're going to distribute the 3. So 3y plus 6 equals 30. Then we're going to subtract 6 from both sides. So 3y equals 24. Then we're going to divide by 3. So y equals 8. All right, I'm going to move on. If you need to pause the video to finish writing that, go ahead and do that. All right, some more algebraic ratios, and then we'll look at what other ways we would use this. All right, so again, when you're solving a proportion, you cross multiply, and I like my variable on the left, so I do that first. 6x, please remember when you cross multiply again, it makes an equation, equals 24. And to solve that equation, we will divide by 6. So we get x equals 4. All right, on the next one, we will do 5y equals 3 times 15, which is 45. Divide by 5, and y equals 9. All right. The last one of this type, again, because I like my variable on the left, I'm going to do this part first. And because we have what's called a binomial up here, we have to put that in parentheses. So 10 times the quantity m plus 2 equals 14 times 5, which is 70. All right, we distribute. 10m plus 20 equals 70. Oh, excuse my 7 there. Subtract 20. 10m equals 50. Divide by 10. M equals 5. Oops. All right, now we're going to simplify ratios. The important thing in this section is that we make sure we have the same units before we simplify. You can think of this as a fraction, 60 over 200. And then you just have to ask yourself what goes into 60 and 200. First of all, important thing that happens here is these centimeters do cancel out. So when we get done, it won't be centimeters anymore. It'll just be a ratio. And by the way, a ratio is, we just said, a ratio is a comparison of two numbers. So you can't ever leave a ratio as just like the number 2. If you get something like that, you have to do 2 over 1. All right, so first thing I notice is they both end in 0, so 10 goes into both of those. So I can simplify by 10 and make it into 6 over 20. And then since they're both even, I can simplify by 2, which will get me 3 over 10. All right, in the next one, you'll see we don't have the same units. We have to get those to the same units first. So 1 foot is equal to 12 inches. So if I change this 3 feet to inches, I would have to take 3 times 12, which gets me 36 inches to 18 inches. Again, the inches are going to cancel out. And 18 happens to go into 36 twice, but again, like I said, it has to be a ratio, which means we have to put 2 over 1, not just 2. All right, in the diagram, the length of AB to the length of BC is 4 to 1, the ratio of those two. All right, that does not mean AB is 4 and BC is 1, because 4 plus 1 does not equal 30. So that means they simplified them both by some amount, and we're going to call that amount x. So we're actually going to call AB 4x and BC 1x, coming from here. And then to get the whole length, we would add those two together. So our equation will be 4x plus 1x has to equal 30. Combining my like terms, I have 5x equals 30. Dividing by 5, I get x equals 6. But what it asked you is, what's the length of AB and what's the length of BC? So AB will equal, plugging this back in there, 4 times 6, which is 24. BC will equal 1 times 6, which is 6. Note they do add up to 30. All right, one more of that type. In the diagram, the ratio of the length of DE to EF is 1 to 2. Again, that doesn't mean this is 1 unit long and this is 2 units long, because that doesn't make 45 units. So that means this is 1x and this is 2x. And then using the segment addition postulate, 1x plus 2x has to equal the whole thing 45, which means 3x equals 45. Divide by 3, x equals 15. All right, so what they asked me to find is the length of DE and the length of EF. So putting 15 back in for the x, DE will be 1 times 15, which is 15. EF is 2 times 15, which is 30. Again, those two add up to 45, like we said. All right, I'm going to skip the other examples. We won't have you do any of that type. So that concludes the first section in our next unit.